In this video, we'll do an example of how to solve for an inverse function. This is your method. You're given some f of x equals whatever. You write y equals whatever it is. But now remember, we're going to try to flip it around. So we're going to solve for x in terms of y. This is actually the step which is the work. Sometimes it's not easy at all to do. But I won't give you any that are really awful. And then after you've got x written as a function of y, you want to swap the x and y. Because this should say f inverse, to write f inverse as a function of x. Because remember, we always like to use x as our independent variable. So let's do an example where we do this. So here we go. Some sort of random thing. This shouldn't be too hard because all of the expressions are linear, right? So even though there's that divide, so we got to work on that a little bit. I want to solve for x in terms of y, so I got to get this guy up. I'm going to distribute, because what I want to do is put all the x's on this side and all the other garbage on this side. So I'm going to do that here. I'm going to put this 2x over here so I can collect out those x's. And then this stuff is just going to be that stuff there. Okay? Now what am I going to do? Pull out the x, right? So I get x times 3y plus 2 is equal to 1 minus 6y. Or x equals 1 minus 6y over 3y plus 2. So my last step is going to be to switch the x and the y. So I want to write this as y equals 1 minus 6x over 3x plus 2. All right, now is it right? So let's take a look at this. Let's take a look at the graphs for a minute. We'll have to do them, but let's put this one up here, and then I'm going to rewrite this one up here, and just call it f inverse of x. So I have 1 minus 6x over 3x plus 2. So it's always the question, like, how do I tell if it's right? Yeah. So one thing you can do for these is you can look at the formula and graph the thing and see if it does what we said it was supposed to do, because we said that you're supposed to flip over the y equals x, right? So our graph should kind of look like that. So if I take this, I know that this graph has an asymptote, right? Because I got 3x plus 6 in the bottom. So if x equals negative 2, I'm going to have a 0 there. So this is going to be my asymptote at x equals negative 2. And my domain is then going to have to not include that point at negative 2. Okay? So I have a vertical asymptote. I also have a horizontal asymptote. So if you remember about the horizontal asymptotes, we're going to take the power of x on the top and the bottom are the same, right? So we're going to take the ratio of coefficients, so it's going to be minus 2 over 3. Right? So let me put that in here. That would be my horizontal asymptote is going to be y equals minus 2/3. And that's what I'm going to expect my graph to approach as I go out to positive and negative infinity. We can fill this up a little bit really quick. If I take x equals 0, obviously this is 1/6, so that's pretty small down here. All right? And then if I Obviously, if I take x equals 1/2, I'll have 0 right in the top. So there's another point here. That's fine. And I mean, then I can put in some other points just to get some idea. If I put in -1, what do I get? One plus 3, -3 plus 6. So what do I have? 4/3. So, okay, that's sort of over here. So that gives you some idea that this is going to do this, which is pretty much what we'd expect. And I can put more points in here, but I also know this guy's just going to do this, so maybe I'll just draw it there loosely. So that's the graph. This is the domain. Now, what's the range? The range is everything but the point at -2/3, because that is my horizontal asymptote. If I look over here at my F inverse, that makes sense, because if I put in -2/3 here, I'm going to get 0 in the denominator. So that tells me maybe I did my math right? So this guy has a vertical asymptote at -2/3. Okay? So my domain is this. 1, 1. I'll try to make it around the same sort of size. So this is my vertical asymptote. So my horizontal asymptote has become my vertical asymptote. And that makes sense because we said we were like flipping around the x and the y, right? So we would also expect our horizontal asymptote here on the F inverse to be the vertical asymptote here. And in fact, it is. If I look at the ratio of the coefficients here, I get -6/3. So I do have -2. So in fact, that range works out, right? And now what about the rest of it? Of course, these guys also flip too, right? If I take x equals 0, I get 1/2. If I put in x equals 1/6, F inverse is 0. If I put in, well, like this point's going to go over there, right? So essentially, I have this, and I have this. Okay? So it makes sense. It doesn't quite look as, well, obvious, perhaps, for the y equals x. Like if I take this and flop it over that line y equals x, I'm going to get this. It's probably easier to see that with the asymptotes than it is to see it necessarily with these hyperbolas, because they're not really that clearly drawn. I didn't draw them that well, but whatever. Anyway, that gives you some idea. Also gives you a way of checking whether you did it right or wrong. Just check that the domain and the range work out with your graph, and that'll give you an idea that you were on the right track.